Alright, so in yesterday's lesson we were working with graphing hyperbolas, and this was the equation that we were working with. So remember I said that there were two forms of an equation that would give us a hyperbola. So this one was that H and K form, which is where you would find your vertical and horizontal asymptotes. Okay, the one we're going to be working on today is of this form. Okay, so it's still a hyperbola. It's going to be the same shape. You're still going to have a horizontal and a vertical asymptote, but how you find those asymptotes are going to be a little bit different. So to find the vertical asymptote, you are going to put denominator equal to 0. So when you do that with this denominator, move the d over and divide by c. Okay, so your vertical asymptote becomes x equals negative d over c. Okay, now I don't want you to memorize that. Okay, there are well, we have two forms of this hyperbola, which is a rational function, and then there's a whole slew of other equations that give you rational functions. You are not going to be able to memorize how to find each style of asymptote individually. Okay, so what you're going to focus on is this right here, denominator equal to 0. Okay, that works to find your vertical asymptote no matter what type of rational function you have. All right, so don't try to memorize x equals negative d over c, because in a couple of days I'm going to be giving you other rational functions and their denominators are going to look different than cx plus d. Okay, so what we want to get cemented in our brain is the pattern for vertical asymptotes of rational functions is denominator equal to 0, solve. Okay, now on finding a horizontal asymptote is y equals the ratio of your leading coefficients. Okay, so in this case our leading coefficients are a and c. Your leading coefficient is the coefficient in front of your variable with the largest exponent. So x to the first, that's our largest exponent. So this would be y equals a over c. Okay, again, don't memorize y equals a over c. Okay, what you want to focus on is this concept of ratio of a leading coefficient. So if our numerator is an x squared instead of an x, okay, you are going to use this concept of the leading coefficient. Okay, so that's what I want you to focus on. All right, so let's look at number 4. Let's find asymptotes. So vertical asymptote, if I want to go vertical, denominator x plus 3 equals 0. Solve that, x equals negative 3. There's your vertical asymptote. Okay, so denominator equal to 0. Horizontal asymptote. Okay, horizontal. Find your ratio of your leading coefficients. So my leading coefficients 1 and 1. Okay, so ratio. Well, y equals 1 over 1. That's just y equals 1. Okay, so sketch in your asymptotes. Again, don't forget, give me a couple labels on your graph so you can figure out, make it easier to read your graph. Okay, now we're going to plot points. Again, I said you could use your... Okay, so I have my graphing calculator. I'm going to go to my y equals. Remember that if you do the alpha x, that will format a fraction for you. So I can do x minus 1 Oops. And then in the denominator, x plus 3. Okay, I'm going to go to graph. Okay, again, we already know it's a hyperbola, so you know what the shape is. We already have sketched in our asymptotes, so you know where those are. So you can use your trace function if you like. So this, I'm on the kind of the section of the hyperbola that's to the right of my vertical asymptote. So one of those points is 0, negative 1/3. Let's see, 1 is 0. Let's see if I wonder what negative 2 is. So negative 2 gives you negative 3. Okay, so that kind of gives us an idea. 0 is at negative 1/3. 1 is 0, and negative 2 is negative 3. So that gives you a little bit an idea, so you can sketch that in. Okay, so let's go. I want to jump over to this other portion, so I'm going to choose a negative 4 because I know that's to the left of my vertical asymptote. So negative 4, 5 is one of those points. Let's see what a negative 5 is. Negative 5 is 3. Let's try negative 6. Negative 6 is 7/3. So 7/3, that's 1, nope, that's 2 and 1/3. Okay, so let's sketch those in. And negative 6, 1 and 1/3. Okay, there you go. So, kind of gives you a nice sketch of your hyperbola. All right, let's talk about domain and range. So domain, remember that domain is going to be based on your vertical asymptote. So my vertical asymptote's at negative 3. So my domain, real numbers not equal to negative 3. Okay, range similarly, it's going to be real numbers not equal to 1. Okay, let's go through and do another one. We'll just do number 5 here. So same thing, let's start with our asymptotes. So denominator equal to 0. So 4x minus 2 equals 0. Move your 2 over, divide, 2/4 becomes 1/2. So x is 1/2, so a vertical asymptote there. Okay, horizontal asymptote. So remember, horizontal asymptote is about the ratio of your leading coefficients. So 2 and 4, okay, ratio. So 2 over 4, oh, sorry guys, move that on you. 2 over 4, oh my goodness, y equals 1/2. Okay, so both of these happen to be 1/2 for your asymptote. So 1/2 here. All right, now graphing it. So let's go back to our y equals. I'm just going to piggyback into this one I already have. So 2x plus 1, and in the denominator 4x minus 2. Okay, graph it. All right, so again, I can do trace. Remember, you can also go to your table and look at a table of values to get a few points. So here I have 0, negative 1/2. What do I get if I go to 1? Oh, yeah, 1 is on the other side of that vertical asymptote. Okay, so I've jumped over there. So let's go back. Let's go negative 1. Okay, -1 is positive 1/6. And let's see, maybe a -3 is at 5/14. Okay, so these points, you're really going to have a hard time telling the difference, especially on our graph when you have such a little graph. So just kind of estimate. Now again, you know that your asymptote is at positive 1/2, so when you go to kind of sketch this in, you got to stay under that asymptote. So, and you can see how angular this hyperbola is, so it's really pulled in tight next to those asymptotes. Okay, so let's find a couple of points on the other side. So remember, x equals positive 1/2 is that asymptote. So if I go positive 1, that jumps me to that other side. So positive 1 is 3/2 or 1.5. Let's see what positive 2 does. Positive 2 is a 5/6. Again, these points is going to be really hard to differentiate between them. But there's my 1, 1.5. My 2, 5/6. It's a little bit under 1. I'm just going to use those 2 points. Again, you know what the shape of it is. You know it's a hyperbola. You know it's going to be in and following along your asymptote. So just a couple of points just to give me a good idea that you understand. Okay, domain, again, piggyback off of your asymptotes. So it's going to be real numbers not equal to 1/2, real numbers not equal to 1/2. Okay, good. And that is going to do it for us for today for this lesson. So hope you have a good day. Let me know if you have questions.